Quantum computing is no longer a thing of the future. It's a revolution happening right now. Picture a world where machines operate at speeds and efficiencies that make our current technology look like child's play. That's the world quantum computing is shaping. Quantum computing is a fascinating blend of quantum physics and computer science. It's not just an upgrade from classical computing, it's a completely different way of processing information. Classical computers, the ones we use every day, operate with bits that are either a 0 or a 1. They follow the binary system, which has been the backbone of computing since its inception. Quantum computers, on the other hand, operate with quantum bits, or what we call qubits. These qubits can be both a 0 and a 1 at the same time, thanks to a quantum phenomenon known as superposition. This allows quantum computers to handle enormous amounts of data and solve complex problems that would take classical computers thousands of years to crack. Moreover, quantum computers also leverage another quantum phenomenon known as entanglement, which allows qubits that are miles apart to interact as if they are right next to each other. It's like having a conversation with someone on the other side of the world as if they're sitting right next to you. This incredible capability enables quantum computers to process data in ways that are simply impossible for classical computers. The potential of quantum computing is immense. From revolutionizing the field of cryptography to making groundbreaking advancements in drug discovery, quantum computing opens up possibilities that we can't even begin to imagine. However, the path to fully realizing quantum computing is filled with challenges. The technology is still in its infancy, and there are many hurdles to overcome. But the progress so far is promising, and the potential benefits are too significant to ignore. Quantum computing is not just an upgrade, it's a completely different way of processing information. The quantum revolution is here, and it's set to redefine the boundaries of what's possible in the computing world. At the heart of this revolution are quantum bits, or qubits. Let's dive into what makes these qubits so special. You see, classical computing is based on bits, the tiny units of information that exist in one of two states, a 0 or a 1. Every email you send, every video you watch, every game you play, all of it is ultimately broken down into a long sequence of these 0s and 1s. But qubits are a whole different story. They're the building blocks of quantum computing. Unlike classical bits, qubits can exist in a state that's not just a 0 or a 1, but a superposition of both. Picture a spinning coin. While it's in the air, you can't say it's definitively heads or tails. It's both and neither, all at once. That's a bit like a qubit in a state of superposition. Now, why is this superposition idea so powerful? Here's the magic of quantum computing. While a classical computer, working with n bits, can exist in one of 2 to the power of n states at any one time, a quantum computer with n qubits can exist in all of those 2 to the power of n states at once. That's an exponential increase in computational power, allowing quantum computers to process massive amounts of data and solve complex problems that are currently beyond the reach of even the most advanced classical computers. But that's not all. Qubits are also capable of something called entanglement, a quantum phenomenon where the state of one qubit becomes linked with another, no matter how far they are from each other. This entanglement further multiplies the computational power of quantum computers, enabling them to perform many calculations simultaneously. Qubits, with their ability to exist in multiple states simultaneously, challenge the very foundations of classical physics. They're the key players in the quantum revolution, opening doors to unimaginable computational power and problem-solving capabilities. Stay tuned as we delve deeper into this fascinating world of quantum computing. Quantum computing isn't confined to the lab. It's steadily making its way into a plethora of sectors, redefining the way we approach complex problems. Let's take a look at some of these real-world applications. Imagine a world where our online communications are virtually unhackable. That's the potential of quantum cryptography. By harnessing the principles of quantum mechanics, it ensures that any attempts to eavesdrop on a communication would be detectable, making our digital world a whole lot safer. But the applications of quantum computing go beyond secure communication. In the pharmaceutical industry, for instance, quantum computers could revolutionize drug discovery. Typically, discovering a new drug is a time-consuming process involving testing millions of molecular combinations. With quantum computing, calculations that would take years can be done in seconds, potentially leading to faster discovery of life-saving medications. Then there's the world of optimization problems. These are problems that require finding the best solution from a sea of possible options. Think of a delivery company trying to find the most efficient routes for its fleet of trucks. Classical computers can take a significant amount of time to solve such problems, especially as the number of variables increases. But a quantum computer, with its ability to process multiple possibilities at once, could find the optimal solution much faster. And let's not forget the potential for quantum computing in the field of artificial intelligence. By processing vast amounts of data in record time, quantum computers could significantly enhance machine learning algorithms, making our AI systems smarter and more efficient. These are just a few examples of how quantum computing could reshape our world. From ensuring secure communication to accelerating drug discovery, optimizing complex systems, and boosting artificial intelligence, quantum computing is poised to revolutionize a variety of sectors. The quantum realm offers unprecedented solutions to complex problems. It's a realm where the impossible becomes possible, and the unimaginable becomes reality. And we're just at the beginning of this exciting journey. You've probably heard of quantum supremacy. It's a buzzword that's been making waves in the tech world. But what does it really mean? Simply put, quantum supremacy is the point at which a quantum computer can perform a task that is practically impossible for a classical computer to accomplish. It's like a marathon runner crossing the finish line while the sprinter is still tying his shoelaces. Now, imagine a race. But instead of athletes, we have tech giants. Companies like Google, IBM, and Microsoft are all in the running, each striving to be the first to cross that quantum finish line. It's a competition that's as thrilling as it is significant. But why all the fuss? Well, achieving quantum supremacy will be a game changer. It's not just about bragging rights or being the first. It's about setting a new standard for what's possible in the world of computing. It's about unlocking a level of computational power that could revolutionize industries from medicine to finance, from artificial intelligence to cryptography. But it's also about more than just power. Quantum supremacy signifies the dawn of a new era in computing, an era where the rules of the game are defined by the strange and counterintuitive principles of quantum physics. It's about stepping into a realm where bits are not just zeros and ones, but can exist in multiple states at once, where information can teleport through quantum entanglement, and where uncertainty is not a bug but a feature. So, while the race for quantum supremacy is certainly high stakes, it's about more than just the prestige of being first. It's about pushing the boundaries of what's possible, about venturing into uncharted territory and paving the way for a future that, just a few decades ago, was the stuff of science fiction. Quantum supremacy is not just a milestone, it's a testament to the immense potential of quantum computing. Of course, there are challenges on this quantum path. Quantum computing, while revolutionary, is not without its hurdles. One of the most significant is the need for error correction. Quantum bits, or qubits, are extremely delicate. They can be easily disturbed by environmental factors like temperature and electromagnetic radiation, leading to errors in computations. This is where the concept of quantum error correction comes in. It's a set of techniques designed to protect qubits from these disturbances, ensuring that quantum computers can operate reliably. But error correction isn't the only challenge. Quantum systems are also difficult to scale up. Today's quantum computers have only a few dozen qubits, whereas a useful, practical quantum computer would need thousands, if not millions of qubits. This is a monumental task that requires significant advances in technology and engineering. Moreover, quantum computers also face the challenge of interoperability. They need to be able to communicate and work with classical computers, which still dominate the computing landscape. Bridging this gap is a crucial task that researchers are diligently working on. Despite these challenges, the future of quantum computing is bright. One of the most exciting prospects is the development of quantum cloud computing. This would allow anyone with an internet connection to access the power of quantum computers without needing to own one. It's a concept similar to how we use cloud computing today, but with the added capabilities that quantum technology offers. Imagine a world where complex problems in fields like medicine, cryptography, and artificial intelligence can be solved in seconds, all thanks to the power of quantum computing available at your fingertips. The potential is staggering. In conclusion, the road to a quantum future is filled with challenges, but with every problem solved, we take a step closer to a revolution in information processing. Despite the challenges, the future of quantum computing holds exciting prospects that could revolutionize the way we process information.